So in this video I am going to explain you what are the steps or what are the different procedure. Okay, a general procedure, you can say general procedure for designing a shaft. Okay, so as a shaft can be a rod type, okay, like this. Sometimes the shaft can be either a solid or it can be a hollow type. Okay, so here this will be the diameter, and for hollow shape there will be two diameter. One will be outer diameter, another will be internal diameter. Okay, so if you want to be design a shaft with a different conditions, okay, so how to solve the problems in the examination? Okay, if you obtain the question on a shaft having different, how to solve? First procedure will start now. Okay, so first you have to analyze the problem to know that the shaft can be designed using two ways. One based on the strength, okay, based on strength, and another one is based on the rigidity. So in a two way we can design a shaft using strength and using the rigidity. Okay, so you should know the equation or general equation for the a shaft which is subjected to strength and rigidity. General equation for a shaft: T by J is equal to tau by R is equal to G theta by L. Okay, so this is the general equation. Now these two equations it terms for strength. Okay, if you want to design based on the strength, you have to use these two equations. And if you want to design based on the rigidity, then take first and last. T by J is equal to G theta by L. This equation to be used when in case of rigidity. Okay, so strength and rigidity. Strength means here there is an bending strength in the equation, that is tau b. Okay, so that's what first and second equation will be used. And rigidity, here this G indicates the modulus of rigidity. Okay, modulus of rigidity. So it comes as based on the rigidity. Okay, so now in both the equation the torque is common. Okay, in both the condition the torque is common. So here the torque, and where J is the polar moment of inertia. Okay, hope these terms also you know. Again I will repeat: T indicates the torque, J indicates polar moment of inertia, tau indicates the bending stress, R indicates the radius of the shaft, G indicates modulus of rigidity, theta is angle of twist, L is the total length of the shaft. Okay, these are the terms will be used. Now, so you have to obtain the torque first. Okay, so from the power you have to calculate the mean torque. Okay, so next procedure will be mean torque. Okay, means the torque you have to obtain. Mean torque can be calculated using the power transmitted by the shaft equation, where P is equal to 2 pi n T by 4500. Okay, so in case of the P power transmitted is given in horsepower. Okay, then now to use this equation, if P is in horsepower and torque is in, okay, these two conditions, torque is in kgf per meter. Okay, this is horsepower, kgf per meter, and where n is the speed in rpm, this equation to be used to calculate the torque. Now same equation where P is equal to 2 pi nt by 60. Okay, so this equation to be used when power is given in watt or kilowatt. Okay, and T is given in Newton meter. Remember Newton meter. Okay, not millimeter, Newton meter. Torque unit will be Newton meter, power will be in watt. Okay, and anyhow it's again in rpm. Sometimes it will be given in rps, so you have to be convert into rpm. Okay, so once you calculated this torque using these two relationship, then you can further go for calculating the bending moment based on this above equation. Okay, first one, this equation, then later you can calculate the modulus of rigidity if it is required. Otherwise, if it is based on the strength, just have to be calculate the bending moment based on the condition of the shafts, like it may be a simply supported beam, cantilever beam, and also different loading conditions, that everything having the separate formula where you have to be substitute all this. Okay, now lastly, how to use to calculate the diameter of the shafts, such as you can use the Gauss theory, you can use the Rankine theory, okay, to determine the diameter of the shaft by, by different variation condition, right? So you have to calculate the diameter of the shaft. Okay, hope this is the general procedure which we have discussed in this video. Okay, so sometimes again you have to be convert the mean torque to the maximum torque. Okay, so if maximum, these are mean torque. Okay, this what we call it is a mean torque, and in some rare case where you have to be calculate the maximum torque. Okay, you have to calculate the maximum torque, so that will be an equation of mean torque into 1.2. okay, if it is mentioned in the question of overload, okay, overload, then you have to use this equation. Okay, so thank you for watching.